All right, so we're on the third day of 5.2 today. Properties of rational exponents and radicals. Does anyone remember what we left off with yesterday? Conjugates. Good job. Yeah.
Oh yes, I love this stuff. I love it. Are you recording?
Conjugates. Everyone remember conjugates and what we talked about them yesterday?
Sure.
On this example, what did we multiply the top and the bottom by? Can someone raise your hand? Yes.
5 minus 3 radicals.
Brilliant.
See, now we're really.
We multiplied by the conjugate of 5 plus the square root of 3, which is 5 minus the square root of 3. We just changed that sign from positive to negative. If it started off as negative, what would we change it to? A plus sign, right? Good. Glad you guys remember that from yesterday. Someone have a question? Someone saying something? Okay. Let's jump to the next example. Adding and subtracting like radicals and roots. So our directions are telling us to simplify each expression. So for letter A, I've got the 4th root of 10 plus 7 times the 4th root of 10. So we have these things that are called like radicals. For them to be like radicals, they have to have the same index and the same radicand. So what's my index on this first term here? What's the index of this term? 4. What's the radicand? 10. Very good. What's the index of my second term? 4. What's the radicand of my second term?
10.
So would you guys say these are like radicals?
Yes.
I would too. Perfect. Brilliant. So, I can add or subtract if I have like radicals. I kind of treat them like a variable. So I just look at the numbers that are in front of the radicals. So I got a 7 here, right? What's the number in front of here? 1. So what do we think I do? Add what?
The 1 and the 7.
The 1 and the 7. Perfect. What's 1 plus 7?
8.
8. What do you think I put after the 8? 4 through to 10?
Yeah.
I don't add the 10s? Very good. So that'd be my answer for letter A. So like I said, you kind of treat it like a variable almost here when we're adding and subtracting the like radicals. The radical and the radicand stay the same, and we just add the numbers that are in front of them. Does that make sense?
Yeah.
Same thing with subtraction. You would just subtract instead of add. Okay? So would someone like to come to the board and do letter B? All right, come on up. Here, I'll give you the iPad. Be very careful, though. This is my personal iPad. This was not given to me by the school.
Okay.
So we have 2 times 8 to the 1/5 plus 10 times 8 to the 1/5.
I feel like it's that. I'm guessing.
Very good.
Okay.
How did you get it though?
That's good.
I added.
Oh, I see now. But you
Very
said
good.
multiply,
So it's 2 plus 10 here gives me 12. Does anyone remember why I'm able to do the 8 to the 1/5 like that, where I just treat it like a radical?
You can turn it into a
I can turn it into a radical. Very good. If I wanted to,
5th root of 8.
it is the 5th root of 8. Very good. So it's 2 times the 5th root of 8 plus 10 times the 5th root of 8. So we can just change it to a radical, and then we can recognize that they are like radicals, so I can combine them. Does that make sense?
Yeah.
So that's why she was able to just jump straight to adding to a 10 and then leaving it like this. So you could leave it like this, or you could write it as 12 times the 5th root of 8. Either one of those will work. Hello. Thank you. Any questions on A or B so far? We good with those? Fantastic. Can I erase and move to C? Very good.
Coach Kaiser, I love that enthusiasm.
I'm trying. Letter C. Do I have like radicals right off the bat? No. They have the same index, right? But do they have the same radicand? They do not. Does anyone recognize anything that I might be able to do, though, that might help me out to simplify this expression?
Can you put those in the same radical? Or
I heard someone say reduce. What are we reducing?
no radicand. 54.
The 54. I can simplify that radical, right?
6.
What's the biggest perfect cube that goes into 54? Actually, let's go ahead and list out the perfect cubes. What is 2 cubed?
8.
8, very good. What is 3 cubed?
18, 27.
27, very good. 4 cubed?
Oh, we already had it. We got it.
4 cubed?
64.
64, 5 cubed,
100.
so on and so forth. Do we already have it?
Yeah.
Yes, we do. Very good. 27 times what?
2.
What's the biggest perfect cube that goes into 54?
27.
27 times what gives me 54?
2.
Times 2. Does everyone see that? That helps me. Why? Why does that help me? Because now I can take the cube root of 27, which is 3. Can I take the cube root of 2? Nope. So that 2 stays under that cube root. And then I still have my minus cube root of 2 over here. Does everyone see why that helps us out? Because now I have what?
Perfect. The radicands and the index are the same.
Very good. They have the same index. They have the same radicand. So this is what we call like radicals. So what's understood to be in front of this second radical?
-1.
A minus 1. So what's 3 minus 1?
2.
So my answer is 2 cube root of 2. Any questions on C? Not too bad? This mask is hurting my ear. Ouch.
Maybe you have it too tight.
It won't go any looser. Any questions on adding, subtracting, like radicals and roots? Can I move on? Oh, I'm going back. We're good? All right. Oops. There we go. Okay, so now let's talk about, those are radicals that just had numbers. So let's talk about radicals involving variables as well. The properties of rational exponents and radicals can also be applied to expressions involving variables. Because a variable can be positive, negative, or 0, sometimes absolute value is needed when simplifying a variable expression. So we got a nice little chart here. Looks nice and neat. It says when n is odd, here's our rule. The nth root of x to the n just equals x. And here's some lovely examples over here. Notice that when my n value is odd, if x is positive, it comes out positive. If x is negative, it comes out negative. Whereas when n is even, it's going to be positive either way, whether x is positive or negative. Okay? So just pay attention to that. And then notice this little statement at the bottom. Absolute value is not needed when all variables are assumed to be positive. So for today's purposes, we're going to make it easy on ourselves and we're just going to assume, or we're going to have all our variables to be assumed positive. So we're not going to mess with the absolute value today. Okay? So just know that when n is odd, x is positive, it comes out positive. X is negative, it comes out negative. When n is even, x is positive, it comes out positive. X is negative, it comes out positive as well. Wait. Once again, the absolute value is not needed when all variables are assumed to be positive. So we're going to assume all our variables are positive today. Any questions on my chart that I have going on here? Can I go ahead and move on?
No.
Okay, I'm waiting. Everyone good? Okay, I'm waiting. We're good. Everyone good now? Oh, okay. I'm waiting. We're good? All right. So here's some radicals here that it wants us to simplify. They just include variables now. We can handle that, right? Yes, we can. That's right. So simplify each expression. The cube root of 64y to the 6th. It wants me to simplify it.
8.
What? Okay, so I got to find the biggest perfect cube that goes into 64. What are my perfect cubes again?
27, 64. Yeah.
Uh-oh. Uh-oh.
It's 4.
What? Is 64 a perfect cube?
Yes.
Yes, it is. So I can take the cube root of it, right? That's what a perfect cube means. So what is the cube root of 64? It is 4. Very good. All right, now I have y to the 6th. The cube root of y to the 6th. Does anyone remember my little trick that I taught y'all on how we can simplify a variable that has an exponent, taking the root of it? I could break down the y's. There is a little bit of a shortcut though. You guys remember, I can take my exponent, divide it by my index. What's 6 divided by 3? There it is. Does that make sense? You don't remember that?
That was like last week, was it not?
I think so, yeah. But you could do it by breaking it down. Because how many y's do I have?
6.
So am I looking for pairs, triples, quadruples?
There's-
Triples, I'm looking for groups of 3. Because it's the cube root, right?
Oh, okay.
Does that make sense?
Forgot about that.
So, what do I have a group of 3 of? I got a group of 3 y's. What else do I have a group of 3 of? Group of 3 y's. So I'm pulling a y out for this group of 3. Pulling a y out for this group of 3. So how many y's am I pulling out total? 2. So I get 4 times y, or 4y squared. But you can use a shortcut and divide the exponent by the index. Did everyone see that for letter A? Yep or doodle. Can I erase A and move to B?
Yes.
Let's do it. Letter B. Anyone have any ideas how I might handle this one to start off? Does anyone remember one of my properties of radicals from yesterday that might help me break this down into something that I can handle a little easier?
You make it into 2. So I know you just take like
Quotient
the
property.
radical over x over 4 and then over the radical of y over x.
Very good. I can break these into their own radicals, correct? So I can get the fourth root of x to the fourth over fourth root of y to the eighth. Does everyone remember that? That's my quotient property of radicals from yesterday. Everyone good with that property? Okay, is this in simplest form?
No.
Why not?
Because they can't be
Because what?
Radical denominator.
Can't be a radical in the denominator. What can I do up top first, though?
You can sample it.
Simplify that. If I take the fourth root of x to the fourth, what do I get? X. So I get x over fourth root of y to the eighth. Can I simplify my denominator? What does it become?
Y squared.
Y squared. Does everyone see that? I divide my exponent by my index. A divided by 4 gives me 2. I could also expand this out. I'd have 8y's. I'm looking for groups of 4. I got a group of 4 y's. Group of 4 y's. So I'm pulling out 2 y's, aka y squared. So you could look at it either way. Is this now in simplest form? Yes, it is. There we go. Look at y'all.
It's the enthusiasm.
It's the enthusiasm.
So,
It's contagious.
Yeah.
Woo!
Changes.
Questions on example 6? We good? All right. Example 7. All right, we're almost done. After this one, we got 2 more slides. That's it. That's it.
and no more after that?
No more slides after that.
Someone get an assignment.
We do, but it's okay. Because I'll tell you why after. But
It's not
let's get through this first. Okay? So, we're writing each expression in simplest form. Assume all variables are positive, so we're not worrying about those absolute values. So letter A, I've got the fifth root of 4, a to the 8th, b to the 14, c to the 5th. Are there any perfect powers of 5 that go into 4? Are there any perfect 5s that go into 4?
No.
Nope. So 4 is just going to stay under the radical. I can't break it down into anything that I can take the fifth root of, can I? Can I break a to the 8th down into anything that I can take the fifth root of?
No.
You take it apart, like split it.
What would I split it into?
Would it be 5 and 3?
Not 5 times 3.
It'd be 5a.
No, 85, 80 squared, or 8 to the 5th and 8 cubed.
Very good. I found the next multiple of 5 below 8. Does everyone agree that the multiple of 5 that's below 8 is 5? Because I can take the fifth root of a to the 5th, right? So I'm breaking it down into something that I can take the fifth root of. Does that make sense? And then a to the 5th times a to the 3rd would give me a to the 8th, because remember, we add exponents when we're multiplying the same base. Does that make sense? So knowing that information for my a, what can I break b down into?
B 10 to the 10th and B 4.
B to the 10th times b to the 4th. Does everyone see that? Because I can take the fifth root of b to the 10th, and that's the next lowest thing before or below 14. Do I need to break c down anymore?
No.
Nope, because I can take the fifth root of c to the 5th. Any questions on how I've broken it down? Or are we good? Okay, so let's start pulling stuff out that I'm able to pull out. Can I take the fifth root of 4? No. What's the fifth root of a to the 5th? A, so I'm pulling an a out. Can I take the fifth root of a cubed? No, that'll have to stay. Can I take the fifth root of b to the 10th? What do I get? B squared, very good. The 10 divided by my index of 5 gives me b squared. Can I take the fifth root of b to the 4th?
No.
Nope, that'll stay. And what's the fifth root of c to the 5th? C, very good. Whatever I was not able to pull out, I'm just going to keep it under my fifth root. Can I simplify anything any further? I cannot. There's my answer. AB squared C times the fifth root of 4A cubed B to the fourth. We good with letter A? Mm-hmm. Mm-hmm. Can I erase A and move to B?
Yes.
All right. Letter B. Is this in simplest form as it is? No. Why?
That'd be radical denominator.
Very good. I've got a radical in the denominator of my fraction, which we learned yesterday that a radical expression is in simplest form when I do not have any radicals in my denominator. Can I simplify that radical?
Yeah.
What can I simplify it down into?
Y to the 6 and
Oops, not 6. Y to the 6 times y squared. What's the cube root of y to the 6th?
Y squared.
Y squared times the cube root of y squared. Does everyone see that? I still have a radical in my denominator though, right? What do I multiply by? If I multiplied by the cube root of y squared, I would get the cube root of y to the fourth. So I'd still have a radical in the denominator, right?
Somebody gotta use the conjugate.
No, not the conjugate. That's good. That's a good thought though,
Something in the
but it's not quite the conjugate. What'd you say?
Y squared minus.
Not quite. Here's a thought. We want to get this to something that I can take the cube root of, right? So what's the next multiple of 3 above 2? 3. So what can I multiply that I'd get y cubed under my radical? The cube root of y, right? So let's multiply by the cube root of y over the cube root of y. Do what?
How can you just do that?
How can I just multiply by it?
Yeah.
Well, what is the cube root of y over the cube root of y? 1, right? If I multiply something by 1, I just get that thing back, right? So we're multiplying by a form of 1. So it's keeping it equivalent. It's just going to look different after I'm done multiplying. Does that make sense? So that's why I'm able to multiply by a number over itself. So up top, what do I get?
X squared cube root y.
X cube root of y over, what do I get downstairs?
Y cubed.
Y cubed. Because I have that y squared that I'm accounting for already. When I multiply the cube root of y squared times the cube root of y, I get the cube root of y cubed, which is just what? Just y, right?
Yeah, y.
And then y squared times y would give me the y cubed. Does that make sense? There's my answer. There is a way I could have approached this that would have taken a little bit of shorter time. I could have just started off by multiplying top and bottom by the cube root of y over the cube root of y. That would give me x cube root of y. And downstairs I would have gotten the cube root of y to the 9th, which is what? Y cubed. So you could have done it either way. Either way will work. Any questions on B? Can I race move to C?
Yes.
All right. You guys are killing it. Keep it up.
Me too, bud.
Thank you. Letter C. 14xy to the 1/3 over 2x to the 3/4 times z to the -6th. So what do you think I'm going to do with that 14 and 2? Subtract it? Divide it. It's just a division problem, right?
Yes.
So what's 14 divided by 2? 7. Very good. If I'm dividing something with the same base, what do I do with the exponents? Subtract them, right? Do I have the same base here and here?
Yes.
Yep, so what can I subtract? Which two numbers? Very good. Remember, it's the top exponent, so it's understood to be a 1 as the exponent of x up here, minus the bottom exponent of 3/4. Everyone good with that? I have a y up top. Do I have a y in the bottom? No. Can anyone think of a way that I could write a y in the bottom to help me subtract exponents? What? Very good. What is anything to the 0 power? 1. So if I write y to the 0 down here, does that change anything? No. Which exponents am I able to subtract for y now, though? 1/3 minus? Very good. Perfect. Everyone good with that? So can someone help me out on writing exponents to subtract for z? 0 minus -6. Because I can write a z to the 0 up here, correct? So remember, I've got to do top exponent minus bottom exponent. So you got to have that minus the -6. Does that make sense? All right. So over here, for my x, I have 1/1 minus 3/4. What would be a good common denominator here?
4.
Very good. 4. What would be the numerator of my first fraction? 4. Very good. So what is 4/4 minus 3/4? 1/4. So I get 7x to the 1/4. What is 1/3 minus 0? 1/3. Very good. And 0 minus -6? 6. Can I simplify anything else? There's my answer. Does everyone see how we handled C? Does everyone see how we handled C? Oh, I cracked myself up. Any questions on C? Can I move on to our second to last? Actually, we have one more slide.
Yes.
Can I move on to my last slide? Yipperdoodle. Let's do it. So here, we're adding and subtracting like radicals. We just now have variables involved, unlike we did earlier. Make sure we're all awake, please. So letter A. I've got 5 square root of y plus 6 square root of y. Do I have like radicals here? I do. They have the same index. They have the same radicand. So they're like radicals. So what would be my answer here? Is that it? Yes, it is. Yipperdoodle. Questions on A? That one's not too bad, is it? Easy peasy. Nope, because we're adding here. Like we did earlier, whenever we just had numbers. We almost treat our radicals like variables. Just regular variables without a radical. So if we have 2x plus 3x, we get 5x, right? So here, we got 5 square root of y plus 6 square root of y equals 11 square root of y. Everyone good with A? Okay, B. 12 cube root of 2z to the 5th minus z cube root of 54z squared. Do I have like radicals here? No, but what did he say to do? Simplify. Let's try to simplify, see if we can simplify either or both of our radicals. Can I take the cube root of 2? No, I cannot. Actually, yeah, I'm going to do that. Can I break z to the 5th down into anything that I can take the cube root of? Z to the 5th? What can I break that down into? z cubed times
Z squared.
z squared. Very good. Does everyone see that? Because now I can take the cube root of z cubed. Let's look at our other cube root. What's the biggest cube root that goes into 54, or perfect cube? 27 times 2. Can I break z squared down anymore? No. Everyone good with that one? Sorry, it's kind of messy over there on the right. Can I take the cube root of 2?
No.
No, that'll stay. Can I take the cube root of z cubed?
Yes.
What do I get?
Z.
Z. You can't see. You can't z. Oh man. So 2z squared stays under my radical. Questions with that first term? The what? Oh, that's z squared. Sorry. Z squared. Okay, what's the cube root of 27? 3. I have this z on the outside. Can I take the cube root of 2 or z squared?
No.
Nope, so those stay. Everyone good with that second term? See where I'm getting all these numbers and variables. Do I now have like radicals? Yep. Same index, same radicand. I have like radicals, right? Now I do have variables involved, so I need to make sure that my variables match up too. Do my variables match up on the outside?
Yes.
Yep. So what is 12 minus 3? So I get 9z cube root of 2z squared. That'd be my answer. Questions on B? Not too terrible? All right. Is everyone ready for the assignment? No?
Yeah, sure.
Yes. Here we go. Okay, it is kind of a long assignment, longer than our usual assignment, but I am giving you more time to work on it. It's not going to be due till Thursday. Okay? Is that fair?
Yes.
Here it is. Pages 252 through 253. Numbers 2 through 70 evens. Due on Thursday, April 15th on Canvas. Pages 252 through 253. Numbers 2 through 70 evens. Due April 15th on Canvas.
There's a lot of problems.
There's a lot of problems. It's good stuff. Good practice. Does anyone have any questions for me before I end the recording?
No.
All right.